to blend all of our knowledge together to solve some polynomials. So if you look at number 23, given a zero of the polynomial, determine all other zeros and write the polynomial as in terms of a product of linear factors. So, number 23 says x to the fourth, an x to the fourth polynomial, and we know that one of the roots is negative 2i. Do you know one of the other roots? Positive 2i. How would I find the remaining two? We could do the plus or minus and then divide them out using synthetic division. My recommendation is if you already know some of them, use those to eliminate some of the possibilities. How would I do that? Right, we could go through and list all the possible rationals. How do I remove the i's from the polynomial? Good. So I know that x equals 2i and x equals negative 2i. Can we synthetically divide by 2i and negative 2i? No, it doesn't work. There's no way to do it. But I can create a quadratic equation. What's the quadratic equation for 2i and negative 2i? X squared plus 4. Can I use that to simplify the polynomial? How? We divide. It's kind of like long division, but we use the box. So x squared, 0x, and 4 go in the box. And I don't really need the 0x, but you definitely want it because it will allow your diagonals to line up. If you get rid of it, it'll still work, but you'll kind of have to search around to figure out where each of the terms lies. So I put x to the fourth in here. How many times does x squared go into x to the fourth? X squared times, and then this will be 0x to the third and 4x squared. Now what? 0x to the third and this box have to add up to be negative 2. So negative 2x to the third. And how many times does x squared go into that? Negative 2x. So this would be 0x squared. And the last one is negative 8x. Now, my x squared diagonal needs to add up to be negative 11. So I have 4x squared. I need negative 11. So I'm going to subtract 15x. Okay? How many times is x squared? Oh, that's squared. How many times does x squared go into negative 15x squared? Negative 15. And this would be 0x. And that is 60. Negative 60. Okay? Now I look at my x diagonal. These terms here need to add up to be negative 8. So how much more do I need? None. I already have it. So my x remainder is 0, which is good. We knew that was going to happen, right? How did I know my x remainder was going to be 0? Nope. How did I know? Well, and let's look at the next one. These two need to add up to negative 60. How much more do I need? 0. How did I know the remainders were going to be 0? Those are roots. It told me one of the roots, and the other one had to be attached to it. So now I'm left with x squared minus 2x minus 15. Does that factor? X minus 5 and x plus So my roots are negative 2, positive 2i, negative 2i, 5, and negative 3. How would I represent that as a product of linear factors? Be x minus 2i, x plus 2i, x minus 5, and x plus 3. So they're both the answers. So you need to list the roots, and you need to list the factors. Yep. Okay. So 25, I can do the same trick. What would be the quadratic equation for 25? X squared plus 1. So I would long divide that polynomial by x squared plus 1. Okay, what about 29? So I need to multiply x minus 1 plus, or sorry, minus I, and x minus 1 plus I. But we dealt with this in the last assignment. There's a fast way to do this. What is it? How do you multiply complex conjugates together? What's the fast way to do it? Remember from yesterday? Something's going to cancel. What's going to cancel? All of the i's will cancel except for the I squared term. But the I squared term is going to go away anyway because I squared is negative 1. So when you multiply through, you need this one, and you need this one, but you don't need the next one because it's going to cancel. And then you need this term, and you need this term, but you don't need the next term because it's going to cancel. And then when you move on to negative I, you can skip the first multiplication and the second multiplication, and all you need is that one. So you can get rid of 4 of the multiplications, which will speed it up. And the second and third multiplication will always be the same. So the first one is x squared, and the second one is negative x, and the third one is also negative x. So it would be negative 2x, and then the constants turn into plus 1, and the I term ends up to be negative I squared. What is the opposite of I squared? It's really just plus 1. So I have x squared minus 2x plus 2. What do I do with this? You're going to divide, and if you look at the, so this is number 29, look at the polynomial. There's something about that polynomial we need to be aware of. There's no x to the third, so the x to the third diagonal adds up to be 0. Yes, that is how we eliminate 2 of the factors. According to the polynomial, there are 4 of them. 2 of them I know, so I take the original polynomial and divide it by the 2 I already know, and that will leave me with a quadratic that I can either factor or use the quadratic formula to find the remaining 2 roots. Okay? All right. 35. Factor each polynomial as a product of linear factors. How would I find the factors for 35? We need to go through the possibles, plus or minus 1, plus or minus 3, plus or minus 9. It's probably worth looking at the sign changes. 1, 2, 3. So positive, negative, complex. 3 positive, no negatives. Well, how do I know it's 0 negatives? Because x to the third can only have 3, so it would be 0, 0, 1, 0, 2. So I certainly want to guess positive numbers. And I really like like to look at the polynomial and add up the coefficients, and that will tell you if 1 works. Does 1 work? Is 1 minus 1 plus 9 minus 9 0? That's one of the roots. So 1 is one of the roots. So I looked at the coefficients. If I tried 1, my coefficients would be 1, negative 1, 9, negative 9. If I add all these together, do I get 0? Yes, which means 1 works. Because 1 doesn't really change anything. I'll show you. So we drop the 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 0, 9, negative 9, or sorry, positive 9, and 0. So if you add up all the coefficients and the answer is 0, that means positive 1 works. Okay? And I found one of them, but the remainder is x squared plus 9. So the other two are i's. So the answer, all it wants is the factor. So x minus 1, x plus 3i, and x minus 3i. Okay? Look at number 50. Something about 50 makes me unhappy. Okay, the fact that it's long makes me unhappy. The negative out front. Can I change all the signs? And the answer is yes, because I'm finding the root. But the answers want the factors. So let's say I find all the factors. There are 4 of them. So I find all 4 factors. Is that the answer? You need a negative out front, or one of the factors needs its signs changed. So if one of the factors was x plus 4, technically you could get rid of the negative and do 4 minus x. But my guess, and you can't always guess what Cynthia's going to do, my guess is there's a negative out front. Okay? Is it a bad idea to graph the polynomials to make your guesses look better? No, not a bad idea. Not a bad idea at all. Will that tell you all the answers? It will only tell you the rational answers, because if the answers have square roots in them, then you get a decimal that doesn't make sense. If the answers are imaginary, they won't even show up. Okay? Okay. I think you guys have everything you need.